Okay, so we can say that in simpler terms, edge computing means running fewer processes in the cloud and moving those processes to local places such as user's computer or an IoT device, which can improve the response time and save bandwidth. Okay, so like this, today's webinar will give you an insight about what edge computing is and other trending technologies are and how much they value they hold for us in the future of the world. Okay, so with this, I welcome our event speaker, Mr. Ramneek Kalra sir. He is a project engineer at Wipro Limited, and he is an IEEE Impact Creator, an IEEE Brand Ambassador, and he has also been a co-chair of V-Power Track at IEEE YESS 2020. He has been chair of technical committee and at IEEE WIE ILS 2020 and co-chair of IEEE Data Science Bootcamp 1.0 under IEEE Madras section chapter. He is also a renowned author and program co-lead of IEEE Computer Society Student Leadership Program under IEEE Computer Society SYP Committee. So with this, I welcome you, sir, and I request Mr. Ramneek Kalra, sir, to share his views on edge computing and other technologies with us. Over to you, sir.
Perfect. Thank you so much, Amisha, for your wonderful introduction. And the people who were asking me about who am I, so I hope now you are aware about me because I got interaction and I got interactive with you on the WhatsApp group as well. And it was really great to note your expectation and what you would like to learn today from today's workshop. Thank you so much to BMSIT student branch and CA chapter for inviting me out today in this evening of Sunday. And it's really great. Thank you everyone for joining me and get to learning about edge computing and the emerging technologies which I will be concentrating on the screen. So let me just share my screen and Shri, can you please let me know once the screen is up?
Sure, sir.
Yeah, I'm just going to share. Perfect. Are you able to see?
It's visible, sir.
Okay,
Yes, sir,
perfect.
it's visible.
Okay, thank you very much. So, good morning, good afternoon, good evening, depending upon your time zone you have joined us today. And thank you very much for joining on Sunday evening. So, today we will be learning much about edge computing and emerging technologies. I will be giving a short demo on a simulation tool. I hope many of you are aware about it, but yeah, let's go ahead. So, what we will be covering today? We will be covering what is the basics of cloud computing, what is edge computing, and why edge computing is required if we have cloud computing already. And I will be displaying some of the bulleted list of emerging technologies with respect to the prediction done by IEEE leaders, computer society leaders. Then I will be telling you how to get started in edge computing domain, what are the different applications, and then I will be going you through a live demo on Cisco Packet Tracer tool. That's the simulation software I was talking about, and then the online tools which you can explore on your own and you can Google it and download it. And last, we will connect for QA. But before starting the session, I would like to make a note to everyone on the call today. Please feel free and please be comfortable with me. While if you have any kind of question during the session, please drop into the chat window so that I can take during the session as well as after the session. Okay, please don't feel shy or introvert. It's fine. I'm also a human. Everyone on the call is also a human. No chatbot or something is there in between of us. Okay, so please feel free. Moving ahead. So, can anyone please let me know what is cloud computing in the chat window? It's a very basic question. What do you mean by cloud computing? Can anyone please place into the chat window? I have two screens here, so you may not like I can see the chat window here, and the slides are on the second screen. So please feel free. I am waiting for your response in the chat window. What do you mean by cloud computing? Come on, guys! You are BTech students. You are bachelors. You are doing your bachelors. You must be aware about basics of cloud computing. Anything. it's not right or wrong. I am not giving you marks on your practical or something. So please feel free to say about cloud computing into the chat window. Okay, we got a remark from Akshar. Cloud computing refers to the hosting and deploying of a web application. Wonderful. Thank you so much. And I would say web application specifically, more often like any kind of application. We can say in that way. Okay. Wow. Wonderful. Nice to see the activity now. Great. Rubni is saying computing like storage, deploying over the internet, different services from internet, on-demand availability of computer resources. Good. Yes, I know when you are very smart and very in a very quick way. You just Googled the definition of cloud computing and you copied in the chat window. Please don't do that. Let's make it more interactive and more engaging with ourselves. What we know. Don't use the don't use the help of Sundar Pichai or Google. Okay, let's be limited to our knowledge. Especially delivering computing application over the cloud, like storage and all. Okay, delivery of computing services like database. Cloud computing is the delivery of different services through the internet to use the remote access. Perfect, guys. That's a wonderful. So it's a great on spot you mentioned about the things like putting the application, any kind of application over to the internet. That's all about cloud computing, right? And you can see on the slides, like in the center, you have kind of a cloud. It's not a proper cloud which makes rain or in the sky. No, cloud means a server. In a technical terms, if I say cloud server is a Windows server, Linux server, or a Mac OS server. Okay, it's a kind of a laptop or a system in one of the data center of any company. So if you can see, there are three devices connected to the cloud: tablet, mobile, and laptop. The application which is running on one device or on the cloud server, it's being replicated to other devices also. So it's like synchronization of the data onto every single device connected to one cloud server. That is the basic foundational pillar of cloud computing. Okay. What are the different advantages of cloud computing and disadvantages of cloud computing? I will be letting you know about edge computing, and then I will be letting you know what is the difference between both and why we step towards edge computing rather than cloud computing. If we do have the cloud computing, why do we need a separate model to learn and experiment edge computing? So cloud computing has a lot of computing power. If I say today, right now, you're going to predict COVID cases in India after 1 month. So how you will do it? You will run a Python script offline, a machine learning script offline in your laptop, or you will deploy the same script over the internet, right? And you will wait for the outcome, and you can use that outcome anywhere. Got it? So it has a more computing power because you don't need to take care about the physical architecture. What are the different server in the data center? Nothing. You just buy a space in the cloud, and there you go. The second advantage that cloud computing has, more storage. It's a scalable. Cloud computing is a scalable model. If I say Amisha is going to buy a 50 GB space, okay? She is already having a 10 GB space. Now she wants more space, 40 GB. How's she gonna buy? So she will pay some money to Google or Microsoft or Amazon to buy a space. After paying, it's like a pay as you go model, right? What you pay, you get that. So as much as you will pay, you will get the space accordingly. So cloud computing has the biggest advantage. It has an ample of space, okay, ample of storage you have. You can store any files online and you can share among your peers. What about the applications? Can anyone please let me know what are the different applications of cloud computing? You can see Uber car is there on the right hand side of the slide. But I want to hear from all of you. What is the basic application you use daily? Can I know in the chat window what are the different applications you use daily? Which is the basics of cloud computing? Come on, guys. Looking forward. I am onto the chat window. What are the different cloud computing applications? Web browser, rightly said. Storage, synchronize. Yeah, it can be Google Drive, OneDrive, or yeah, it can be anything, Apple Drive or anything. What next? Yeah, yeah. Oh, these are the products. Please let me know about the application. Don't tell me about the company names or other things. Let me know about the application. Search engines. Okay, great. TeamViewer, yeah. Conference tool, video conferencing tool, screen sharing tools, right? TeamViewer, AnyDesk, or any kind of application which runs on the cloud, which uses internet. Antivirus. Oh, that's nice to know. Yeah, we can say like firewall is deployed online on the cloud and we are using it. Text editor. Okay, more specifically, I hope you are saying about the compilers, code compilers who are on the cloud. We can use high power server for complex application running remotely. Wonderful. Thank you, Akshay. What else? My main ambition of today's session, if I will able to explain edge computing, cloud computing to the people who don't belong to CSC and IT stream, then my session is successful. I want the electronics, electrical, ICE, and other stream except computer science and IT to talk and engage with me so that I can get to know that yeah, they are also understanding these concepts. Adobe, yeah, Adobe Cloud is there. Virtual machine, wonderful. Because right now work from home is going on. Industrialists and all the people, professionals in the corporate are using virtual machines, virtual networks, yeah. File storage, yeah, we covered it. Games, yes. Games like LAN gaming or other types of games, online remote games. Yes, we can say that. Games is a wonderful, I would say, example of cloud computing. What else? Great. So these are the different applications. Now you know, like cloud computing runs on internet, right? For working in cloud computing, for using cloud computing, you need internet, right? And you need a proper bandwidth, right? And I would say the biggest disadvantage as well as advantage of cloud computing is security. Because if you see right now in COVID scenario, we have a lot of scams, ransomware attacks, and all cybersecurity scams, cybersecurity attacks. What's this? This is security, right? This is kind of like we have the advantage of security. We can actually make it strong according to our organizational need. But the limitation is also security, right? So security is one of the important pillar which has the advantage as well as the disadvantage in cloud computing. Okay. I hope you all are clear about cloud computing now. Can I know yes, no in the chat window? Are you all clear about cloud computing concept? Then we will move ahead to the next advanced model. Perfect. Yes, 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 yeah, yeah. Okay, great, wonderful. So let's begin ahead and let's move on into edge computing. Many people say edge computing is kind of fog computing, but there's a slight difference between both. So people actually industrialists use edge computing. So I will be covering the concept and I will be taking the terminology edge or fog interchangeably. Please don't confuse yourself. Edge computing and fog computing are the same, but there's a little, I would say, tweak according to some of the research study, but we will not concentrate on that. Now, if you can see on the architecture platform, if I use a pointer here and I will make you understand. See, this is the main architecture of edge computing. Now in the cloud computing, we don't have the middle layer. In the cloud computing model, we have the user layer, which we have like Android devices, tablets, laptops, and it is directly connected to the cloud layer, where we have the internet storage, computation going on, processing going on, prediction going on, anything, data analytics going on, all the things. So applications is directly connected to cloud layer. It's the model of cloud layer, cloud computing. What's about edge computing? So in edge computing, we have the physical layer, which is the bottom layer, if you can see. We have the potentiometer, we have different types of sensor, we have renewable, we have industrialist, I would say application like solar, wind, any kind of things, okay? These are sensors and controllers that comes onto the physical layer. Now the tablets, all the devices are also nearby to the sensors, right? And then we move on to the second layer, which is edge layer. So edge layer includes the storage element, the computation element. Can anyone please tell me what is the difference between a microcontroller and microprocessor? Anyone in the chat window? Microcontroller and microprocessor. What is the main difference between both of them? because all the appliances, like in the edge layer, we will be using all the types of microprocessor controllers. Yeah, microcontroller do specific tasks. Okay, what's other difference? Processor can also do a specific task if we allowed to. What's the main difference? I'm asking what's the main difference between controller and a processor? Extra memory for microprocessor, okay? Only in one chip, okay? What next? Processor processes input and produces output. Controller also does the same thing, no? We just put some input and we will get the signal out of it, right? Multitasking, okay? Controller operates as at higher speed because of less memory. Controllers as a single task microchip. Okay, on chip memory for microcontroller Vandana. Okay, what next? I just mentioned you with the aspect of cloud computing and edge computing. Think of it. What is the main difference? I just explained you the architecture of cloud computing and I explained you the architecture of edge computing. What is the basic power? Okay, power. I can say yeah. No worries. Memory, yeah, that's also one of the point. Controller has less memory, processor has more memory. There you go. Rupak has mentioned the correct thing. Microprocessor contains only CPU, but controller. Oh, I guess that's reverse. You mentioned kind of reverse. Like microprocessor, if I say Raspberry Pi, what are the advantages of using Raspberry Pi over Arduino? Raspberry Pi has a storage. Raspberry Pi has an operating system, right? We can do the computation, we can do the prediction, we can do the processing offline onto that itself. For controller, if we want to use, we will connect controller to an online cloud to make something like ThinkScapes we can connect or kind of different platform. So that's the main difference. Microprocessor has an operating system, controller doesn't have. So it gives an edge that we can perform computations and all those things onto the microprocessor rather than on the controller, right? So in the same way, edge computing is actually the application of these IoT devices, all these controllers, processors. How we can do the computation processing to not to go to the cloud layer, but rather we can do all the things offline without using internet. That's all about edge computing. Finish. This is the concept of edge computing. Okay. Now if I say I have a sensor here, okay, in the bottom layer, I have a sensor, let's say an example, current sensor, okay. Now I am doing a prediction of my home electricity bill, that yeah, what is the current consumption of my each appliance, and I am going to predict to the consumer, like after 1 minute or after half an hour, what will be the consumption of this appliance on the basis of real-time data analytics or real-time data collection onto the microprocessor. That microprocessor will be on the edge layer. Okay. Now, microprocessor has also a limit of a storage. It can be 8 GB, it can be 16 GB, depending upon the memory card you are using, right? Because Raspberry Pi and all other microprocessor commonly use memory card, SD card for storage. So if you see, like, if you have a historical data, a lot of data, now you will do the computation offline. That will make the task easy. Now, if you are uploading a video on your Google Drive, it will take a lot of time to upload and download, right? But edge computing is not about that. Edge computing is like uploading and downloading without internet, without latency. Okay, there's no time lag. There's no time lag. You can just do all the things offline. So that's like, what are the different advantages with respect to that? So it works on personal area network. We can use Bluetooth, Wi-Fi. You can say LoRaWAN and other kind of personal area network protocols. It works on wireless network. If you know, Raspberry Pi works on Wi-Fi as well. It has a Wi-Fi inbuilt. So it works on wireless network. You can connect with nearby components or devices, like a router in your home, right? Like a home gateway in your home. High security. Why high security? Now, if I say the risk of cyber attack increase when you are connected to internet, okay, people can attack your devices, people can trace back your devices. Okay, this is the IP address, this is the subnet, and I can trace back and I can attack if you are on internet, if you are connected to cloud layer. Why high security in edge computing? Because we are doing all the things offline, we are not connected to internet at all, right? So that's more secure. It's a private network, you are not connected to internet at all. So what is the biggest advantage? As I mentioned, we have a very low latency. And just mind this statement, for the upcoming decades, we are going to experience about 5G. 5G is going to roll out soon in India. So we will be experiencing about that thing. So 5G and edge computing are both of the things which will couple together, and it will be shining a lot into the market in coming decades. Just mind that statement. And I'm really strong believer of that, because 5G actually works on low latency. If 5G will be rolled out with a very, I would say, honest bandwidth, because in India we don't get the honest bandwidth, right? We don't get proper bandwidth which is expected from the consumer, or which is expected from the producer of the internet. So if 5G rolls out on its own 100 gigabytes per second speed, so you don't need internet at all, because all the things will be so fast. You don't need the use of internet. You want the things which will work offline. Okay, if I say I have a smartwatch, that's a wonderful example of edge computing. My smartwatch is connected to my Android phone. Okay, and real-time data is storing into my app. If I want to take a backup of it, I can just connect to Google Drive and it's there, right? So that's the concept of edge computing. May I know how many of you have understood about it? Yes, no, yes, no. Can I see in the chat window? Have you understood about cloud and edge computing now? What is the main difference between them? Yeah, yeah, great. Yes, it does include IoT devices. Yes, I will let you know in the live demo, Rupert. What else? Okay, all are clear, right? Perfect. Let's move ahead. So now, why edge over to the cloud computing? Why it is required? Where is the data stored? In EC. Can you please edge computing? Okay, where is the data? It's on the microprocessor itself. It's on the microprocessor itself, because microprocessor has an operating system, right? Like your Windows or Linux or Mac OS. So in operating system, we can store the data offline onto your SD card, onto your local disk, right? So the data is storing there, as well as we are doing the data computation offline itself, right? That's the advantage of edge computing. Okay, let's see from the simulation here. So why, like, this is the scenario before edge computing. Okay, check it out here. We have a data center here from where the internet is coming and where all the data is stored. And then we have a industry, a lot of industries here. We have a solar plant, and we have a, like, now see, now I want the data to be computed. I want a prediction from the transportation department here, or from a solar plant or something, from solar plant to my data center. Okay, I want to predict how much the production of the electricity will be done. I want to know that. Now, if we don't have the edge computing deployed, if we don't have a microprocessor connected to the solar panel offline, that's very difficult. Because if I say there are 5 industries, 6 industries right now connected to our data center, all of them simultaneously on real time they are sending requests to our data center. Do you really think latency problem won't be there? Obviously, there will be a lot of latency, no? There will be a lot of traffic. Have you seen that issue, like whenever you are trying, let's say an example, 12th class results are coming up, right? And that's a wonderful example of cloud computing. And whenever like 12th class results are coming, everyone is on the website. Lot of traffic. You can't load the website. You can't actually check out the result. Why? Because there's a lot of traffic on that particular website, on that particular space, or a particular server in the data center, right? So that's the thing. That's a disadvantage. Latency is a lot of the thing. Now, after applying edge computing, how we can solve it? Now you see, center is here. Now, out of the data center, we can take some of the monthly data on which we want to do the prediction offline. Okay, cloud layer has a lot of years of data. Now, from that, I will just extract out some of the monthly data, which is very much sufficient for me to do the prediction. Okay, and I will deploy onto the fog node or edge node. Okay, node means the Raspberry Pi or microprocessor or IoT devices. Okay, I will do the computation and the processing there, data analytics, data processing, anything onto the fog node. Now it's a distributed model. Earlier it was a centralized model. We were having a cloud data center, and all the devices were directly connected to the cloud data center. Right now in edge computing, it's a distributed model. Data center is here, I am having a copy of all the data on a different application basis, okay, in a different places across the city or across the globe. That's the advantage of edge computing, right? So now it comes to the emerging chart. Like what is the kind of lot of emerging technologies which are coming up in the industries? And I took the reference from top 12 technology trends for 2020, and 2021 report is also out from IEEE Computer Society. You can visit computer.org to check out the report, and you can properly check out how we can actually what are the different technologies right now industries are working on. Okay. So before beginning, let me take some questions on cloud computing and edge computing from all of you. Please feel free to place questions now about cloud computing and edge computing. Then we will begin ahead. Okay, we have one question. Can cloud computing security issue be resolved or issues will be there? See, it's kind of a dicey question, as I would say. Like, let me tell you one example. I have my smartphone, okay, and I'm right now using PIN. Okay, I'm using a PIN security, and I am using fingerprint as well. Now, let me know. Both has a disadvantage, right? I am sleeping, and someone come and just tap my finger on the fingerprint sensor, and my phone is unlocked. And there are a lot of techniques. We can boot something, or we can boot some software or something to break the security. Okay, so what about that? That's the thing. Like the more security we will increase, the attacker will think from that point of view, right? Why hackers are there? Why attackers are there? They are thinking from advanced model. If we increase the security, they will think the loopholes of that, right? It's really impossible if a new technology comes and we don't have a loophole 100%. That's really impossible, right? We will have a loophole, and attackers actually focus on that. I hope that solves your query. And obviously, there will be a lot of issues depending upon the security level you are doing in your organization or at your individual level. So, but still, fog node is connected to cloud. No, not at all. Vamsi, it's like the fog node and the edge node is connected to application before. Okay. The difference between cloud layer is a temporary connection. If you need that, you connect. That's not compulsory statement. That's an architecture. Okay. If you want to connect the cloud layer, if you want to use the data storage availability there, you go ahead. You can connect it. It's for a temporary purpose. Okay. If you don't need it, don't use it. Fog and application layer is sufficient. We don't need to use cloud layer completely. Okay. So why not update it? Okay. Okay. I would say like there are lot of loopholes. I can point out a little bit. Like if you say biometric is there, right? We have a lot of attacks on the biometric last year. We have ransomware attack. What do you think? Like your Windows, Mac OS, and Linux is safe? I don't think so. Your Windows Defender, it can be also attacked if an attacker got to know about it. Ransomware attacks comes on the Windows platform maximum with comparison to Linux and Mac OS platform. So do you really think Microsoft is not working in a very right way? They are working in a very right way to secure the consumer data and all those things. But loopholes will always be there, no? When you make a product, you will get a lot of disadvantages as well, which you will put into the future scope, which you will work ahead. So every time something comes up in the market, it will have a lot of disadvantages. Maybe in the first time we won't see it, but that's the thing, right? That's a dicey question. That's why I mentioned cloud computing has advantage security as well as disadvantage security. Okay, how to perform operation that require use storage and memory with the use of edge computing, because edge computing has a disadvantage. Okay, so here's the thing. That's what I mentioned. Like we have a lot of database into the cloud layer. Okay, we have a gigabytes or terabytes of data in Google Drive. Let's an example. Now, here you don't need to predict a lot of data. You don't need to analyze the whole of the data, right? Out of those year-based data. Obviously, when you do prediction, many times it's like you are working on some of the monthly data set, not on the year-based. If you want to work on, increase the size of your memory card. That's what we can do. It's like plug and play. In cloud, it's like pay as you go. So there you pay, and in the backend, Google people or Microsoft or data center people plug in a memory card or hard disk on what you paid. In edge computing, you have that server in your hand, right? So you can increase the memory card size. That's what I can say. And that's how you can perform the operations and data analytics. Yeah. Rupak, can you explain a bit more how 5G will be implement? No, see, 5G won't implement edge computing. Okay, it's a combination of both. If I say 5G will come, you will have a lot of bandwidth. Okay, you will have a lot of internet. Now, many of the operations you will need to perform offline. Let's say an example of Wi-Fi. After the advanced model of Wi-Fi, Wi-Fi is like that breaks the walls also. You can connect through the walls. It's a radio communication. And Wi-Fi is kind of light sensor. You are able to see the light, and the light is giving you the internet. It's a Wi-Fi model. So it depends upon the application actually. And 5G will 100% integrate with edge computing because 5G, like the applications which industries are working right now, they're working on the localized operating, localized data processing, localized data computation, how they can perform the fast computation. Let me say an example. Let's say like accident happened on a highway. Okay, now we need to report to ambulance right away to nearby hospital. How you can do it? You will wait, you will call, or you will raise a ticket on an app or website. That will take a lot of time, right? So how it cannot be done? If we connect a microprocessor to the smart camera on the highway, and that camera will automatically trigger ambulance to nearby hospital with a local connection, no internet, right? And that data, that real time, if that hospital is not having facility, that hospital can use 5G and then transmit that longitude, latitude of that accident to next nearby hospital. So these are the different application, how the industries are working with the test bed, not the proper 5G bandwidth, but only the test bed of it. Okay, with edge computing and 5G integration. Advantages of cloud computing over edge computing, are there any? As you said, it can be advantages. Okay, advantages of cloud computing over edge computing. I would say I can't see actually internet as an advantage. That's what I mean. Like if you see internet as advantage, it can be advantageous for you, but from my point of view, security and data privacy is on the top. Consumer want that to be secure. Okay, I don't think there's kind of advantage of cloud computing over edge computing. That's why edge computing came up in the market, and it is so trending, and right now and researchers are working on it. Perfect. Perfect. We have less time. We have 19 minutes left. Let's move ahead and let's talk in the interactive session in the last. So, emerging technologies chart. Like these are the top technologies right now, industries are working and researching on it. Like artificial intelligence at the edge node. As we are talking about edge computing, see it's on the top. It's ranked number 1. People are working how to implement AI, deep learning, machine learning onto edge computing. That's on the top. Second, non-volatile memory interfaces and application. Many times, like if I say, you take an example of Arduino. Arduino doesn't actually store the location, store the, I would say, that particular point when you shut down it, when you power off it, right? But Raspberry Pi did. Raspberry Pi does. Why? Because Raspberry Pi is an operating system, Raspbian. So it has the database, it has the cache memory. It can store the whole the things into the hard disk or the RAM. When you restart the Raspberry Pi again, it will restore at that particular point. So non-volatile memory is very much required so that the memory and the data won't lost after restarting the system. Digital twins, that's really wonderful technology. I would say you should explore on computer.org as well as on Google, checking out some of the research paper from IEEE Explore Library or Springer or Google Scholar. A lot of people are working on this digital twins. It's like if I say right now I am here, okay, and I want to twin myself, like I want to make a copy of myself into another place. Obviously, live streaming is there, it's fine. But when I'm speaking right now, I'm sitting as a physical space here. Okay, so I will just copy myself into a virtual reality. That's digital twin. Or it can be extended to Raspberry Pi. Like we have a Raspberry Pi. Do you know about SIM card, virtual SIM card? Can you guys please let me know yes, no in the chat window? Virtual SIM card. Have you heard about this? Okay, no worries. So, virtual SIM card, yeah, eSIM, yeah, that's the same. So, virtual SIM card or eSIM is kind of a provision by a lot of the telecommunication companies. What they do, what they does actually, you ask to download the SIM, okay? You will get a virtual number and you will download the SIM instead of plugging into your phone, okay? And this is the wonderful example of digital twin. You are twinning a physical application into a virtualized world. Okay, so that's the concept of digital twin. You can have a look on Google more. AI and critical system, as I mentioned, like ambulance system, emergency situations, practical delivery drones, and many of you heard about Amazon delivery drone. It's working, right? It's a lot of things. Lot of models have been thrown out, and Indian government is also working on it with Amazon and other companies. Adaptive manufacturing. That's one of the wonderful, I would say, aspect what industries, manufacturing industry is looking forward. How we can implement the automation into the industry. If I am having a manufacturing plant for manufacturing my phones and uh, you can say collating all the hardware together, how I can automate it using robotics, AI, ML, and all those things. Right now, we have a lot of robotics hands and all those things in the industry, but we are not able to find the space of AI, ML, and all these emerging technologies into manufacturing plant. So that's one of the sixth rank technology. Cognitive skills for robots. That's what humans can perform. How we can implement the AI at such level that a robot can be compared to a very easyable or I would say critical mission task. A robot can be deployed into army or somewhere, right? So that's the thing. AI ML applied to cybersecurity. That's very much wonderful domain to explore, like how we can predict ransomware attack gonna be there on the laptop after 2 days, right? If you can predict it, then you can save a lot of millions dollars of a company, right? How you can actually check out the ports which are open onto the server so that no one can get entered into it for any attack or any kind of ransomware attack. That's also one of the great domain. Legal related application to reflect security and privacy. That's also most important because everyone over the planet right now in COVID scenario, they're working on data privacy. How we can make our consumer data more secure. So what are the legal ethics, legal policies? So that's a non-technical domain, but yeah, it's also one of the emerging domain and technology which you can explore. Then adversarial machine learning. That's also one of the important thing. How you can actually make machine learning so compatible according to the application, so universal. If I say you need to develop a machine learning model for a school, okay, irrespective of any application, like Google Classroom. Google Classroom is a model for virtual classroom. Depending upon the teacher, depending upon the student, they can customize it, right? They can buy the brand toolkit, they can put their logos onto it, they can connect with Google Drive, they can connect with their school website or college Google account, Google Cloud account. So that's the thing. How you can implement the machine learning prediction at the various societal problem that will give a lot of advancing and connecting all the streams AI, ML, deep learning together, right? Reliability and safety challenges for intelligence system. Now, if we are going to deploy AI, we need to check it out for the safety as well, right? We are going to deploy AI, we are going to check out the automation and robotics, those things. How we can make sure that it is safe for the consumer and for the users. Quantum computing. I hope you all are shocked like why quantum computing is on the 12th rank in the last. But the thing is like it's very new. It's on the very initial phase. Right now NASA, Google and other big companies are working on it. Right now it's not deployed for the consumer. Yeah, Microsoft has a programming language which is called as Q Sharp, which you can learn and you can experiment on Visual Studio. But it's not so open. But yeah, it's also one of the emerging technology what's going on in the industries. Okay, Now, how to start with edge computing? What are the different things? What are the different technical stack you need to know before getting started into edge computing? So, as I mentioned, we have a three layer, right? The physical layer, edge layer, and the cloud layer. So, for the cloud layer, you can better know about cloud platforms like Salesforce, Amazon Web Services, Google Cloud, IBM Watson, Microsoft Azure, Oracle Cloud, or anything, right? Any other software as a service cloud platform. Then coming to the edge layer, right? We can know more about machine learning, big data, Docker, Spark, and all other, I would say, big data analytics and I would say data processing techniques, machine learning, all the things which you know, ML, AI, all those things comes together and you can implement onto the edge node, right? As I mentioned, microprocessor as an operating system, you can deploy all the things on it and you can do the computation and the processing without using internet. Coming to the physical layer, now I hope like maximum of you are from CSC IT. Maybe some of the people on the call are non-CSC and non-IT. That's the advantage for all of you guys. When I am a pure CSC engineer, my stream was computer science engineering when I did my bachelor's. So I want to know how hardware and software can couple together and I can know more about it. So edge computing gives you an essence. Edge computing gives you an opportunity to learn about Arduino, Raspberry Pi, and all other IoT devices, sensors, and connect with your software applications, right? So that's a coupling of all the engineering fields together. So that's how these are the basic technical stack chart which you can learn, which you can explore on Google. You can go with some of the courses. I will be letting you know about those courses platforms as well as some of the tools which you can use. Okay, now coming to the edge computing application. Why is it so important, right? What are industries working on? So autonomous vehicles, Tesla, right? You know, every autonomous vehicles is there who is using internet, who is using offline micro sensors onto their cars. Google is also working on it. Amazon is also working on smart cars. Tesla has already rolled out automation. So automation vehicle is one of the wonderful example of edge computing. Security solution. Again, as I mentioned, every time when we advance our thing, there will be lot of loopholes. So security solution is also one of the wonderful domain to explore from application point of view. Smart speakers. Now, if you know Google Homes, Alexa, and all those things, these things work offline as well, right? You have an option in your mobile, in your smartphone. You can download whole dictionary of Google Assistant and you can talk with Google Assistant offline, right? You can deploy Google Home, you can connect to your Wi-Fi router without internet, you can talk with them. So that's the thing. That's also one of the wonderful example of edge computing. Healthcare industry. That's really wonderful. I visited last before lockdown. I visited one of the hospital clinic near to me, and they do all the stuff like ultrasound, all human test, and all those things. So what they have did, they have a Geo router, Geo company. They have an internet router, and that router is connected to every single floor. Okay, and every single nurse or a doctor has a smartphone application. So that smartphone application works offline with the router who is connected, which is connected to internet. Internet is not so much required, but to exchange the data between the floors of the building, there we go. That's a wonderful example of edge computing. Retail advertising. Now I would say like Google Map is there, Amazon is there. You can do all this stuff offline. No, if you have attended Google keynote, they have augmented reality based Google Map direction, right? So it works offline. You can have virtual reality embedded into your phone, augmented reality embedded in your phone. Some of the compatible devices are there by Google, Motorola, Samsung, which worked on this. Video conferencing, yeah, today we are using internet to work on this webinar and we came together onto one platform. But what happened? It's a research domain. Right now, people are exploring the application of it. How it would happen if I can make a personalized video conferencing tool for an organization, for a college or for a school, for our own use in a private network, right? So that's a wonderful case study. Okay, let's come back to the Cisco packet tracer shortly. Let's move on to the online tools first. So these are the different tools, simulation tools on the left hand side. You can explore on GitHub, like there are iFogSim, Emulator Fog, and a lot of other open source tools available for GitHub for edge computing, so that you can explore and you can better know about it. On the right hand side, you can see a lot of platforms and academic where you can explore about edge computing, IoT, basics of networking. Because if you want to step into edge computing or cloud computing, you need to know about basics of IoT and computer networking. So there's a wonderful platform, Cisco Networking Academy. They actually give you the free courses, self-paced courses. You can Google it and you can explore those courses with a wonderful tutorials and training modules. Raspberry Pi portal, Arduino portal, and Cisco DevNet portal. That's also one of the big things. Okay, so we have 7 minutes to go. Let me just quickly open the Cisco Packet Tracer so that I can just give you an overview of it. Okay, I hope you are able to see the Cisco Packet Tracer. Can anyone please confirm me? Are you able to see the screen?
Yes, sir.
Okay, perfect. Let me have some H2O so that I can have some energy. Perfect. So, guys, have a check. This is a tool from Cisco. It's a simulation tool where you have a lot of components, like the hardware components in data center or the Arduino Raspberry Pi. What do you have? But we don't have operating system option in Raspberry Pi. That I can make you sure. So on the left bottom, you can see network devices. So in network devices, we have different types of routers, switches, hubs, wireless devices. Like this is a home router, you can say, right? This is a cell tower, like the cell tower in fields and industry, right? And you have a server also. You have you can say this is also one of the router, right? Security appliance, you can say a firewall or something. We have separate firewall also, 550 firewall. And then you move ahead, then you will have a cloud. Okay, the WAN network, wide area network. Okay, move ahead, we have end devices, so you can note we have PC, laptop, server, printer, phone, the analog phone, landline phone, Android TV we do have, wireless tablet we do have, right? We have smartphone and other things. And in the home you go, the smart appliances which you want to explore in IoT and edge computing. AC, smart AC, smart coffee maker, battery, and all those different types of appliances which you want to use. We have a webcam as well, right? We have a water level monitor as well, a lot of things. Solar panel, you can have a solar panel as well. Moving ahead, we have smart city appliances, beacon is there, Bluetooth sensor, fan is there, car is there, you have a smart car as well. So it's a very wonderful platform where you can explore and a lot of things are there. Smart LEDs there, right? We have a street lamp as well, smart lamp, which you can deploy in your street. Then you move ahead, then you have different type of I would say sensors, like trip sensor is there, right? We have a wind detector, we have a wind turbine as well. Okay, power grid appliances are there. We have a blower for production of the electricity. Moving ahead, then it comes to the IoT part on the edge layer. So MCU is the controller, okay, controller unit, and SVG is the mini computer. You can say microprocessor, okay. So this is one. And moving ahead, we have different type of actuators like speaker we do have, servo motor we do have, smart LED, motor, LCD, and heating element on all those things. Sensors, as I mentioned, push buttons, and all different types of sensors you can explore. Okay, coming to the application now. Let's take an example. We do have a simple sample in Cisco Packet Tracer. If you go into file, you can see a lot of samples are already there. Okay, so you can learn from the samples or you can go with your scratch model. If I go ahead in IoT, if I open IoT, let's say an example. Let's take a scenario of street data collector. Okay, let's open the street lamp. Okay, now see, we have a wireless router here. and we have a smart car. Okay. Now this wireless router, which is a Raspberry Pi, or which is connected to a Raspberry Pi, and this Raspberry Pi is acting as a server now. Okay. You can note on the screen like we have wireless 0, we have Bluetooth. So it has both of the thing, Wi-Fi as well as Bluetooth. So according to that, it is connected to the smart lamps, right? If I go ahead and if you see like M is right now green, right? It means street lamp is able to detect that car is near to me. If I take the car near to this one, M will highlight, right? If I go here, if I go here, same reflection. Now the main important thing where you will enjoy using Cisco Packet Tracer. Why? Why is it so enjoyable? Let me open the simulation model on the right hand side. Now I want to transfer a data from the server to street lamp 2. Okay, I just clicked on the server and I clicked on the street lamp 2. And I'm going to play the simulation. Let's see the packet transmission, how the networking works here. The packet transfer to the server, the router, and what router does for the first time, it transfers the packet to all other people, because in the first time router doesn't know to whom that packet is destined, designed to, right? Now you can see, like, one second, let me hold it. Now onto the street lamp 2, you can see the packet is loading. All other street lamp is like close, right? Close. Onto the street lamp 2, it's loading. It means the packet signature is matched with street lamp number 2. Right, let's go ahead. Let's see what happens next. Now the packet confirmation will be given by street lamp 2 to the server. Okay. And router also now obviously it won't say that, yeah, I am not able to direct it. Let me give back the request to server, so that server can let me know if the packet is perfectly done or not. Now you can see a tick right on the server, and on the right bottom you can see it's a successful. Right. So that's a wonderful, I would say, platform as well as wonderful tool which you can explore on your own for your own research papers and research projects. Perfect. That's all from my side. Let me just that's my LinkedIn profile and my website from where you can connect me. And okay, I guess like it will be clickable. Yeah. Perfect. Thank you very much for your great patience. And let's open the floor for queries now.
Okay, so we'll now open the portal for Q&A session. So anyone in the audience, if they have any questions, or they can post it up in the chat box, or they can unmute and ask. So
Yeah, thank you so much, Mohammed. Thank you so much for your remarks. Guys, please be comfortable. The same thing if I ask for a school student, they will be quickly coming in such a way, right? So if you have any type of query regarding edge computing or cloud computing, so please let me know.
Sir, can you give me some project regarding cloud computing, sir?
You are stealing the ideas from me, huh? I think like better you Google it, better you find out some of the research paper, what's going on right now, and for research paper, I would say finding you can explore Scholar, Google Scholar if you know. If you don't know, let me just share this link into the chat window. I believe Aisha, it will be recorded. Yeah, it will be uploaded somewhere. Other than that, you can find onto my website. I will upload on my website as well today's session.
Excuse me, sir. I have a question.
Yeah, Sri.
Earlier, you told about the 12th standard and 10th result, how the page gets stuck, or how it might not show results after some time. So, how do you think it might be solved using edge computing?
Oh, okay. That's a very wonderful
No,
question.
I'm
And
just asking it in a vague way. I'm not asking for a perfect solution or anything.
no. Yeah,
I know.
I
Yeah,
yeah, I got it.
yeah.
Yeah, that's actually the scenario. If we take an application of a results announcement or a feedback system for your own college, okay. And I am not using any website or kind of thing for collecting the feedback of the teachers from students right now in your college. I'm just deploying the website locally on the server. Now, anyone outside your college won't able to access it, right? Because it's not on the internet. That's on the local server, and that server is connected to every single computer of your college. So that's the example of edge computing. I hope it
Uh,
relates.
yes,
Yeah.
sir. I thank you, sir. And one more question I had when you were discussing about Tesla automation cars and stuff about applications of edge computing. So, does every new technology like edge computing, if given time, it might become cloud computing now, sir, because it expands into several branches and memory might be required for it to operate.
Okay. See, as per my research onto the vehicular network, and I have been very much passionate about this thing because we have I forgot the name of that pin. We have a 16 pin under the steering wheel of your car. So that particular pin that has a kind of a storage device or CPU or a microprocessor, you can say, that collects all the data, all the sensor data of your car. Okay, when you visit a service station, they connect their laptop with that pin, and that synchronize the data into your laptop so that we can get a knowledge about it, right? So that's what it depends upon the application actually. How edge computing can be converted into the cloud computing. As I mentioned, cloud is already there. If you want to use it, otherwise leave it.
Thank you, sir.
Yeah. How do you think storage problem of edge computing? I mentioned you can go with a cloud layer. Cloud layer is already there. You can use the cloud storage. But if you want to use it offline only, increase the memory card. Increase the size of your memory card. That's only one of the solution. Okay, I hope everyone is cleared on the topic, and thank you very much for joining the today's talk. It was really wonderful to connect with all of you, and thank you so much for your invitation. And if it is comfortable, like, can we have a quick group pic?
Yeah, I request everyone to turn on your video so that we can take a group picture.
Thank you very much for your wonderful remarks, guys. It's
That's
good
so
to know.
nice.
I'm glad that you liked it, and I'm glad that you learned something new today. And that was my objective. Thank you very much for joining. Yeah, please quickly come on the camera. Let's take a very quick group pic so that we can put this Sunday evening into a memory of my webinar records and BMSIT memory record. Yeah.
Yes.
Do we have all the people, Rumi? I guess net is slow at my end. I'm not
Yeah,
able
yeah,
to
yeah.
see everyone.
I have taken the pictures. Almost
Oh,
everyone turned on videos.
one second. How you took it? We didn't pause or anything. One second. Okay,
Okay.
guys. Let's make a V. Let's make a V. Victory to the session and victory to IEEE and have a smile on your face. Now take it.
Yeah.
Done.
Yeah, done.
Wonderful. Thank you everyone for joining. And I will be. You can connect me on LinkedIn. You can check out my website. I have shared in the chat window as well in the
So,
WhatsApp group.
yes,
So
so one
I
more
will be
thing.
leaving. Yeah.
So we had some general questions about your IEEE experiences and professional career. We would like to ask about it. Are
So
you
right
okay
now
with it?
in the edge computing session itself or afterwards?
Uh, I it's
Okay, go
are
ahead. Go
you
ahead. Go ahead. Go
okay?
ahead.
Okay.
Yeah. There's one comment from Mohammed, and I guess like, sir, you look like Sundar Pichai, and I would say like this is the popular comment I have got from a lot of people from my network. I don't know how.
Yes, sir. So can you
Hoping
tell us about your IEEE experiences?
what aspect, like there's a lot of things to discuss about IEEE.
Yeah, briefly you can say for.
Okay, I joined IEEE in my second year, 2016, and right now my fifth year is going on. And I would encourage all of you on the call who are not an IEEE member, please join IEEE because IEEE has a lot of advantage. Today I am getting this knowledge. Today I am getting this opportunity to learn from all of you by volunteering myself as a speaker to this event, right? And these guys who are organizing this event, they are getting an opportunity to increase their professional skills, soft skills, professional skills. These are the skills, these are the extracurricular activities what industries are looking forward, right? So as an IEEE, as a proud IEEEan, I would say there are only three fundamental advantages of being an IEEE. That is participation, volunteering, and networking. PVN model. You can just Google it. PVN model of IEEE. My article will be on the top, or you can find it onto my LinkedIn. So that's what I can tell in such short time. PVN model is actually one of the biggest advantages of IEEE. You can go from a global team. You can volunteer at any level. You can connect with any professor, any researcher, any professional across the globe. So that's what my experience is so far with IEEE.
Thank you so much for sharing this, sir. I would hand over to the moderator.
So, so we'll wind up the session since nobody has any other questions. So, thank you, sir, for joining us and for giving us some insights about cloud computing and edge computing. And then I would like to thank BMSIT IEEE CS chapter for giving up this opportunity to organize this event. And thank you all in the audience for joining us.
Thank you guys. Please stay safe and stay home. Bye bye. Take care.
Thank you, sir.
Thank you, sir.